Hi there everyone, welcome to my tutorial on complex numbers. Complex numbers are where algebra gets a little bit more difficult than a lot of us are used to. First we had arithmetic, which was just numbers. Then we introduced some variables, which threw a lot of people off. People often say that they don't like letters in their math. And well, we're about to add another letter. That letter is I. And I is equal to the square root of -1, which introduces the question, if the square root of -1 is I, what do you square to get -1? What I mean by that is, if we have the square root of 4, we can break it down into, well, we know that this is equal to 2, but that means that 2 times 2 is equal to 4. Now I know that seems obvious, but as it pertains to the concept of a negative, there is no number that you can multiply by itself that will give you a negative number. For example, if you multiply -2 times -2, you result with a positive number. So you cannot have a negative in a radical, which is why we've been taught so many years that you can never have a negative in a radical. So some mathematicians somewhere along the line decided to call that letter I. That would make it so that you can have the square root of a number. That is negative. The theorem for that states that if you have the square root of a negative number A, then you can take out the negative as long as you put an I next to the radical, because you're factoring out the I. Another important theorem to know, or I guess just a concept, is that if I is the square root of -1, that means that I times I is equal to -1. I hope you see where I'm getting that. I'm just writing down these theorems so that we can reference them while we go through our questions. We also have the addition and subtraction of complex numbers. That's a little bit of a longer theorem. I won't write it all the way out. I'll just explain. If you have a complex number 3i, and you've got a rational number 2, 3 plus 2, let's put this in parentheses, and you add that to another parentheses, 6i plus 3. This theorem states that all you would do is add the imaginary parts, they're not real, and the real parts. So 6i plus 3i gives me 9i. And no magic involved there. And then we are left with 3 plus 2 is 5. And that's how you would handle imaginary numbers. Multiplication is a little bit more advanced. What I mean by that is, if you multiply imaginary numbers by non-imaginary numbers, they become imaginary numbers. For example, if I have 3i plus 1, and I multiply that by 2i plus 3, I am left with a FOIL problem. I'm sure you've heard of these. FOIL. First, outer, inner, and then last. So let's go through into that. 3i times 2i, well, we've got 3 times 2 is 6, okay. I times I is I squared. So let's write that, I squared. And now we're going to do our outer. 3i times 3 is 9i plus 9i. 1 times 2i is, well, that's 2i. and 1 times 3 is 3. But up here somewhere I referenced that I squared, I times I should write that, I times I is indeed I squared. And that is equal to negative 1. So, going back down, we've got 6 times negative 1. So that gives me negative 6 plus, well, 9i plus 2i is 11i, plus 3. So I add my like terms, negative 3, well, sorry, negative 6 and positive 3, and we're left with negative 3 plus 11i. So that's how imaginary numbers behave. I think that we should go through some examples of these. I think I have a book that I'm looking through. What did I do? Oh, I scrolled all the way to the left, or to the right. I think that's a great idea. I'll do that. I'll just stay here. Let's write this down. We've got 3 plus 2i. And we're going to add that to 9 minus 3i. So like we said before, we're just going to add our like terms. We've got 3 and 9, and that'll give me 12. And we've got 2 and negative 3. Well, that'll give me negative 1i, or negative I. And that would be your answer. Well, that would be your answer. Let's try something a little bit more involved. That was kind of like the example I gave beforehand. This one's a little bit tricky. Negative I minus 2 minus 6 minus 4i minus 5. Oh, this is in a parenthesis. Minus 5 minus 2i. Okay, I guess it's a little bit more complicated. The first thing that we should do is distribute this negative sign into both of our parentheses. This negative into this negative. So I'll just rewrite negative I minus 2 minus 6 distributed into the 6, and plus 4i, and then we're going to do minus 5 because this negative sign is distributing into the 5, and then negative times negative is positive, 2i plus 2i. So let's group our like terms. I've got negative 2 minus 6, which is, let me write the I first. Negative I minus 8. Okay, these are done. Plus 4i minus 5 plus 2i. I probably should have done that in that same step. Let me scroll down a little bit more. So we've got, well, let's just do that here. Negative 8 minus 5 is negative 13. And we've got negative I plus 4i is positive 3i, plus 2i is positive 5i, plus 5i. Wonderful. All we did was distribute. Now, I guess this I stuff isn't so difficult after all. How about we try some products? That's always fun. We will do the square root of 2 minus 4i times the square root of 2 plus 4i. We've got a conjugate. And there is a property of complex conjugates in this book. I guess I should write that down. Let me write down it and then we'll interpret it. A plus bi times bi times a minus bi. And what does that equal to? A squared plus b squared. Now we can go through and do this, and it'll wind up being the same thing. We can distribute or FOIL, and it'll take us a couple minutes. But I think that what we should do is use our knowledge of the theorem and use that to our advantage. So let me label these. I've got A here, and I've got A here. I'm going to call this A then, because it's the same in both places on my theorem. And now I've got positive bi. Well, here's my bi, positive. And here's my negative bi. So this is going to be my bi. So let's label them A and B. My A is equal to the square root of 2. And my B is equal to that's going to be, because I'm not going to include the I in it, it's just going to be 4. Also not including the sign, because the sign changes and the I is not at the end, so we don't need it. So I should wind up with, well, what is A squared? What is the square root of 2 squared? The square root of 2 squared. Well, if you didn't know, the square and the square root are going to cancel, and we are left with just 2. Awesome. And then the square root of 4, or b, as found here. So we've got the square root, or why am I saying the square root? The square of 4 is 16. So we have to just get it how it's written in the theorem, and we will wind up with 2 plus 16, which is equal to 18. If my handwriting's a little bit sloppy, I'm getting used to the pen still. Sorry, guys. I think that's all the important concepts of I believe so. I guess we'll call it a day. Good video, guys. Good video. Why am I saving that? I'm not.